Okay, hello everyone. Welcome to yet another AP Calculus lecture. This time we'll be covering Unit 4, or going over review. So, just a quick disclaimer once again. The AP is a trademark that is affiliated with College Board, and that means whatever material you see here will not guarantee that, or it is not endorsed by College Board, and may or may not help you succeed on your exams. But that aside, quick thing about 5Hive. Yeah, I made this review session. 5Hive is basically organized by this dude Lance, and we're essentially a volunteer organization with like 80 volunteers right now. If you feel like it, please go check out 5hive.org because we have a bunch of articles over there. I'm pretty sure AP Calculus has been fully finished, and there are some other subjects that are also in the process of finishing or are fully finished. And you can also submit FRQs for various subjects and get them graded. Yeah, and furthermore, if you want to join 5Hive, then click on one of our members' tags next to their name on the Hive tag, and you should see a link to the application. And then, yeah, yes, that's why it's named 5Hive, yeah. Alright. Well, expectations, yeah, feel free to just ask questions whenever. I'd appreciate it if you guys participate using chat, because we'll be going over some questions, and we will have a kahoot at the end, so make sure to stick around if you can. And then at the end of the lecture, I'll send out this feedback form, and I'd really appreciate it if you guys filled it out. So yeah, without further ado, this is Unit 4, which is the contextual applications of differentiation. So this is going to be dealing with how we use derivatives in real-life situations. So a quick overview of this lecture. Basically, we'll have a summary of each topic, and then we'll cover a couple of sample problems, and then move on to the next topic. So these are all the topics we're going to go over that are present in this unit. I'll be using this online whiteboard. You can just like demonstrate things and work out problems if you guys need a little more explanation. And yeah, it should be all. So let's get started then. Alright, so starting off, topic 4.1 is derivatives in context. So as you guys may or may not remember, derivatives are essentially rates of change, and we can use these to solve real world problems that involve rates of change. So things like the number of people entering or exiting an amusement park at a certain time or over a certain interval, or like let's say the difference in price due to inflation over like 5 years, things like that. So the derivative is the instantaneous rate of change, so the slope at one point of a function. And then the units of the derivative are basically like distance over time, or whatever unit over whatever unit. So like usually on the bottom you'll have time or whatever's being put in, and on top you'll have your output. And then yeah, so one crucial thing about this unit is make sure you guys know what like a positive or negative derivative means when dealing with your problem. So like a negative derivative in the context of like water filling up a container would mean that the amount of water flowing into the container is decreasing. Stuff like that. And yeah, this will basically bridge the gap, and this will allow us to understand things like accumulation and change over time. So, and it'll also come back to the fundamental theorem of calculus. So, quick sample problem. If we have the population of, so let's say we have the population of a bacteria in the lab modeled by this equation, P over T, where T is our hours. So T is the input here, which means when we get our unit, it'll be something something per hours. That'll be the structure of the units of our answer, because the input unit will always be in the denominator of the whole unit. So now that you know this, what do you think the derivative of P at 4 equals 150 means in context? Just like give it a guess. But yeah, please make sure to spoiler your answers. Have I added the slides? Oh, I can do that really quickly. Give me 1 second. Yeah, but anyways, yeah, question is correct. Give me 1 second. I'll be back. Okay, if you're looking at the 2026 lecture schedule, then the file should be in there now. So if you want to have that open on the side instead of the lecture schedule, I can share the link right here. Yeah, the spoiler used 2 vertical lines before and after your message, but yeah, it looks like most of you are getting it correct. And yeah, you can also use the command /spoiler. Yeah, okay. Yep. Yeah, okay, now it's fixed. Yeah, okay. Alright, well, most of you gave it a shot, and yeah, I guess a lot of you got it right. So what that means is the population itself of the bacteria is increasing at a rate of 150 bacteria per hour at hour 4. So the reason it's bacteria per hour is, if you remember here, the population of the bacteria is the output, and the time is the input in hours. So you do output over input, which is bacteria per hour. And that's your answer. So when you're solving things on the exam, and especially on FRQ, because on FRQs they will like dock you points or just give you no points if you do not add units to your answers. So please make sure to remember to put units if they're asking for it, and just do it anyway, just to be safe. I mean, Mouse, you did get it right. It was just a little differently worded. Yeah, mostly you got it right, but do try to keep it in an output over input form. So like bacteria per hour, or like people per minute. When would it be bacteria per hour squared? That would be the second derivative. So if you wanted to see how fast the rate was changing, like, because right now the population rate is 150, right? But if you wanted to see, oh, how is the rate changing over, like, let's say 5 hours? So when is it like 25 bacteria per hour? When is it like 40 bacteria per hour? Yes, you need to specify that it's bacteria as part of your units. Don't just write 150 per hour. Yeah, most of the time, they will specify if it's in like millions of bacteria or like thousands of bacteria, but most of the time, if you don't see like if you don't see a millions or something, assume it's singular bacteria, or assume it's singular units, because they'll make sure to specify if the output isn't like millions of bacteria or something similar to that. I guess on graphs, they might ask you to... There might be like one instance where you don't have specific units, but most of the time, you'll have a unit. They'll give you units if they want you to write units in the answer. So most of the time, it should be clear what your units are. Yeah, no problem. Okay, any other questions? Alright, you guys want to move on to the next problem / topic? I think there's some practice after this, so. Alright. Okay, so this topic is on particle motion. So this ties into physics. So for those of you taking physics, this is probably a familiar concept at the very least. So, as you know, velocity and acceleration are essentially rates of position and velocity respectively. So that means if we take the derivative of position, we get velocity. And if we take the derivative of velocity, we get acceleration. So when dealing with velocity and acceleration, you have to pay special attention to the sign of the derivative, because that can influence the real life behavior of the particle or thing you're working with. So like if our velocity was greater than 0, then that means, like, let's say it's a car driving on a road, that means we're going to the right. Or if it's let's say like a spider climbing up a wall, then a positive derivative means we're going up the wall, and negative means the opposite, we're going left or we're going down. Now there's a key difference here, and this will come up later when we do integration as well. Yeah, when velocity is 0, it's at its rest, but speed is the absolute value of velocity, because speed does not account for direction. Velocity does account for direction, that's why it's negative and positive, but speed doesn't. So when you're calculating speed, make sure to use absolute value, because there is no such thing as negative speed. So another thing is your speed will increase when the velocity and the acceleration have the same sign. So if they're both positive or they're both negative, then your speed will get faster and faster. But if they have opposite signs, then that means your speed will start slowing down. Yeah, same thing with total distance. With total distance, you have to use absolute value, because you can't have negative distance. But anyways, the reason this is like, imagine you're walking forward, and like the speed at which you're walking forward increases, right? That's a positive velocity, positive acceleration. So that's why you speed up. But let's say you're walking forward and you start slowing down while walking forward. Well, then that's positive velocity, but negative acceleration, since the rate at which your position is moving forward is slowing down. So if you have positive velocity, negative acceleration, you end up slowing down. So just remember that same sign means you're speeding up, and opposite signs mean you're slowing down. Okay, so another quick sample problem. So let's say a particle is moving along a line, and we can get its position using this function right here. S of t equals t cubed minus 6t squared plus 9t. So find the velocity and the acceleration at t equals 2, and based off of the velocity and acceleration, is the particle speeding up or slowing down at those points? So remember that velocity and acceleration are just derivatives of position and velocity, and then remember that same sign speeds up and opposite signs slow down. Yeah, direction isn't accounted for when you do total distance. Yeah, okay, that is the correct velocity function, but now using that, see if you can find the velocity and the acceleration when t equals 2. Okay, yeah. Let's see. Sunflounder, that is correct. Yep, okay, good job, Mouse. You found velocity. Now try to find acceleration. Close. Make sure to plug in t equals 2. The important part here is t equals 2. Because we're trying to find velocity and acceleration at one point and then decide whether it's speeding up or slowing down at that specific point. Yeah, sign analysis. Yeah, okay, it is slowing down. That's correct. Yep, okay, George Washington. Okay, well, it wouldn't be neither. It would just be that the particle is slowing down. Yep, correct. Correct. Yeah, good job. Yeah, that's correct. Careful, Ray, because your calculation for velocity is a little off. Yep, false, that's correct. Do you have to mention it's a point of inflection since a of t equals 0? No, it's not asking for a point of inflection here. Or there's no need to calculate that it's a point of inflection, because to say that it's a point of inflection, you have to show that the sign changes, which you can, but then you have to use a number line, and that's not really necessary here. Yes, you plug in t equals 2 into your velocity and acceleration functions, and then you use the values you get out of those to decide whether it's speeding up or slowing down. Okay, dark ice, you're on the right track with your velocity and acceleration, but do remember that if they have opposite signs, or actually, yeah, since acceleration here is constant, or it's 0 in this case, it wouldn't actually be slowing down. It would mean that what's wrong with the velocity? Nothing's off with the velocity. It's just your acceleration should be 0, not 6, because it would be 6t minus 12, and then you plug in 2. Yeah, the velocity would just be constant in this case. So a little bit of a trick question, but the particle is actually not speeding up or slowing down, because since our acceleration is 0 here, that means our velocity isn't changing. So in that case, that means the speed is constant as well, because speed is just the absolute value of velocity. Ah, okay. Yeah, okay, that's correct. But yeah, anyways. Yeah, okay, yeah, I can see that. Yes, that's correct. That is how you solve it. I think you had it correct the first time, yes. Because, yeah. So like, even though velocity here is negative, since acceleration is constant, speed stays constant. Right, acceleration is 0, speed stays constant. Okay, well, yeah, here's the solution. Looks like most of you got it correct. So yeah, you plug in, this is the function for velocity, and if you plug in 2, then you get -3. And then you take the derivative one more time to get the function for acceleration, and then you plug in 2, which would become 12 minus 12, which is 0. And now since acceleration is 0, it's not positive or negative, which means that the particle is not slowing up. Wow. It's not speeding up or slowing down, since there's no opposite sign. Okay, moving on. So there are contexts other than motion when dealing with real-world problems. Like, you could be talking about like the examples up here, like economics or biology, like that question we had earlier where it was dealing with the rate of population growth. You could be dealing with the reaction rate in chemistry, or like heart rate over time. So there are a variety of applications for derivatives. It's not necessarily always just in like a physics context where it's like position, velocity, acceleration. So when you're dealing with these different contexts, it's always crucial to remember that you need to understand what the signs of the derivative mean in that context, and also what units are being used. Are there any questions? Nope. Okay. So another sample problem here. Let's say you have a company and their profit is given by the function p of t, And t here is measured in months, so keep that in mind for your units. So if the derivative of p at 6 is equal to negative 3.5, what does this mean in context? So focus on what this means in context. These bullet points here are just to kind of guide you. So like think, what are your units of input? What are the units of output? What are the units going to be of the derivative? And then whether the sign is positive or negative. So yeah, as someone asked earlier, whether you didn't know whether there's like millions of bacteria or whatnot, as you can see here, they specify that it's in thousands of dollars. So yeah, when they give you similar problems on the exam, they will specify if it's not just like singular in terms of unit. Yeah, Ray, that's correct. Good job. Okay, I'm getting more answers. Yep, that's correct. Good job. Yep. Yes, that's correct. Yeah, lemon, that's correct. Yep, that's correct, George. Sunflounder. Yeah, that's correct. But yeah, just make sure that in this case, you're focusing on what the derivative at 6 equals. Yeah, make sure there's no space between the spoiler and the slash command. How do you cover your answer? Type slash spoiler and then tab, and then you can type your message. Yeah, Boreas, that's correct. At month 6, the company lost 3,500 that month. Well, it wouldn't be for that month specifically. It would mean that at month 6, they're currently losing $3,500 every month. Yep, that's correct. Okay. So yeah, I think we've gotten a good amount of answers. So I'm going to go ahead and erase the derivative bond the first, you adjust the units depending on the derivative? Yes, that is correct. So if your initial derivative was like feet per second, then your second derivative would be feet per second squared. Yeah, that was worded correctly. I could figure it out. Yeah, Adams, that's correct. Good job. Yeah, no problem. Okay, so I'm going to show the solution here. So yeah, as most of you said, at month 6, the company's profit is decreasing at a rate of $3,500 per month. Yep, that's correct, Mouse. Yeah, spot on. Yeah, here I think you would have to specify profit because the function's output up here is mentioned as a company's profit. Oh, yeah, what's your question? For double derivative, it's really simple. You just take your input derivative or your input unit from the first derivative and square it. So if you had like unit over time, then your second derivative becomes unit over time squared. If you had, like, let's say things per feet, then your second derivative becomes things per feet squared. That's all there is for the units on the second derivative. At that, yeah, it's the average rate of losing money at that point. It's not that it's lost 3,500 at that point specifically. What? So if it lost $3,500 at t equals 6, then it would say p of 6 is negative 3.5. And then since we're dealing with the derivative here, it means at that moment their profit is going down by that amount. If you integrated it, yeah, you'd get the, if you integrated the derivative, you'd get the amount gained, or the total like net gain over that time. Net gain or net loss. If you integrate position, yeah, when dealing with real life context, integrating like position is kind of weird because there's no real like context. I wouldn't say after 6 months because you're dealing with t equals 6 months. Like you're dealing with the derivative at that point. Yeah, items. As I was saying earlier, it's the average rate of losing money for that instant slope. Close. It's more like specifically at t equals 6 months, their profit is going down. So just think of it like it's not their actual profit, but like if you were to pause time and look at their profits, at like how fast your profit is going down at that point, then it would be negative 3.5 thousand. Yeah, as Ray said, make sure to specify at month 6. Okay. I mean, you can think of it as a coordinate, but in reality, it's more of a slope. Yeah, it's not exactly the coordinate, like an XY coordinate. Yeah, like that. You can honestly just think of it as like slope and then add the units after. It's much easier to do it that way instead of trying to think about it in context and then figure out the thing. Yeah, that's correct. Okay. Well, moving on. This is probably the harder of the topics that you'll see throughout this unit and throughout Calc AB. So this is related rates. So what related rates is now you're essentially comparing derivatives or using multiple derivatives with respect to time instead of like with respect to x or with respect to y as you normally would. So the way related rates work is you use the way it works is you use implicit differentiation with respect to time. So I covered implicit differentiation last time. That's where you derive both x and y with related with you derive them both with respect to t. And this is gonna apply in a lot of situations such as like finding how fast the height is increasing based, like, imagine like a context where this would be applicable is if you have a barrel and it's being filled with water. They'd ask you like, okay, if the amount of water pouring in is this much, how fast is the height increasing, and then you'd have to use the volume of the barrel and take the derivative of the volume and then plug in stuff and solve. Honestly, yeah, I'd recommend drawing the question, like at least, especially for problems like, let's say, like the ladder problems where they're leaning against the wall. I would really recommend that you draw a triangle and label like the ladder, the distances, the rates, and all of that, because that'll really help you when you're plugging stuff in to not mess things up. So yeah, you'll have to remember like area formulas and then some volume formulas. There'll be a reference sheet on the exam with a good amount of formulas on there, but I'd recommend to memorize a couple others as well, just you don't have to look them up every time. There should be a ladder question. If there's not, I can look at one. Yeah, there is a reference sheet, yes. But yeah, you'll have to look at area, volume, and like ratios as well. And you'll essentially be substituting things a lot and then plugging things in after differentiating. Are ladder problems really uncommon? They are uncommon. They're on the because they're like the most simplest. Yeah. If there's no problems, I don't think I put any in the slideshow. There might be some, I think, in the covered, but if there's not, I will look up some from an FRQ as well. But yeah, let's check out this. Yeah, okay. So the key you want to do here is when solving these, make sure you identify like what is changing versus what's not changing. So like, let's say in this image here, if you have a funnel that's leaking water, well, the height is changing, right? But the actual like height of the funnel or the radius of the funnel are the same. So you'd like label those as constants and then label the water height as like dH over dt. And then they'd probably give you dH over dt. No sound again. Hold on. Yeah, I'd recommend, yeah, leave and rejoin should work. Okay. Alright, looks like sound still works. But yeah, the key here is, as the topic name suggests, you really need to figure out what the relationship is between the things you already know and the things you're trying to find. That's like the most important part here. Can I walk us? Yeah, there should be an example after, and I will walk you guys through there. Okay. Okay, so this is a triangle related problem. So give this a try, and then I will pull up a whiteboard or something to work with here. And work you guys and get through it. So ignore these bullet points. The only thing I want you guys to answer is this part, the last part of the question. So if the balloon is going up at 5 meters a second and the person is 30 meters away from the balloon, how fast is the distance between them changing when the balloon is 40 meters high? So I just want you to focus on the rate of change of the distance between the person and the balloon when the balloon is 40 meters in the air. So if you're going to try and find sides here, then make sure you remember the Pythagorean theorem, right, for triangle sides, because that's what we're dealing with. And you will have to derive or differentiate the formula and figure some other stuff out as well. Okay, last I remember, the content of the reference sheet was it had volumes for everything from like triangles to cones, I believe, along with the surface area. This is I wouldn't assume that it's a 3-4-5 triangle, but you can assume that it's a right triangle at the very least, and just plug in from there. Okay. Yeah, I'll verify the answers after because I am gonna work through this one. Or I'll go check the answers after. And then but yeah, I'd recommend drawing out the triangle here and then labeling the sides with the different distances, and because that'll help you visualize kind of what's going on and what you need to find. Okay, looks like we're coming to a conclusion here. Yeah, no, they'll give you a majority of the volume formulas that they themselves are using on their problems. So I'd recommend memorizing a little bit here and there anyway, just to be safe. Like for some of the more exotic things like a hexagon or something, that I'd recommend, but otherwise you should be fine. Okay. So far all the answers are the same. So it looks like we're coming to a conclusion here. Okay, Droson, I don't know if that's correct. You might have missed a sign here or there. Yeah, I think the distance, how do you find the horizontal distance rate? Well, since the guy is not moving, you can assume that the rate distance is 0 for horizontal. Yeah, Sunflounder, looks like it's correct. Yeah, make sure, that's why I said like draw it out and visualize it. And if you notice that like something hasn't like been explicitly stated, then that means that you should just be able to figure out based off of context clues. Okay, nice. Looks like most of you are getting it. Okay, I'll wait like another minute and then I'll go show you guys the answer. Yep. Okay, wow, whole explanation. That's good. Yeah, definitely writing out that entire explanation shows that you know what you're doing. So, good stuff. Okay, I think most of us have answered, so I'm going to go ahead and show you guys the solution here. So, yeah, the distance is 4 meters per second. That is the answer. So, as you can see here, you use the Pythagorean theorem. We don't know this derivative here, which is what we're trying to find. But we do know that if this is 30 and this is 40, then this has to be 50, which is a 3-4-5 triangle earlier, as someone put it. And we know that this rising is 5 meters per second. And yeah, I know it's a great drawing. And this distance here isn't changing at all, right? So when we take the derivative, or implicitly derive our Pythagorean theorem, we end up with this. We get 2z times dz over dt, which is what we're trying to find, equals 2x, which is 30 meters, times dx over dt, which is 0, so that entire term just gets deleted. And then we're adding 2y dy dt. Now we know what y is, and we know what dy dt is, so we just plug those in. So when we plug in all the values, the way you'd find z here is you'd either use Pythagorean theorem or you'd use the 3, 4, 5 triangle. Yeah, make sure to that when you're deriving, you don't like accidentally drop a constant. So just derive everything as you would normally. But yeah, once you derived or differentiated the Pythagorean theorem, you would then plug in what you know. So here z is 50, which we found from Pythagorean theorem. And then we don't know dz dt, because that's what we're trying to solve for. And then we plug in, this one's 0, because remember our dx dt is 0 here. So that means whatever 2x is doesn't matter, because we're going to multiply by 0 and just get 0 anyway. And then we're adding 2 times y, which is 40, right? And then we're multiplying by dy dt. So 2 times 40 times 5 is 400. And you're dividing by 100, so dz dt equals 4. Yeah, it's not my best drawing, so I'll probably do better. Alright. Anyways. Yeah, this one's better. This is a math written out by hand, if you guys wanted to just like take a picture and see how it applies. Yeah, go ahead and take a photo, because this will apply to pretty much any problem that involves a triangle. So if you want to, feel free to add it. Yeah, you can add it to your notes, you can put this on a flashcard and try to remember the entire process. But yeah, feel free to like take a screenshot real quick. Okay, so another one asked for I know someone asked for a volume problem, so here you go. So if water is poured into a cone at a rate of 2 cubic centimeters per second, right, and both the radius and height of the cone are 10 centimeters, then find the rate of change of the water inside the height of the water inside the cone when the water level is at 4 centimeters. So this is a different kind of problem that is also very common. You will see it'll be like water pouring out of a funnel, a conical funnel, into like a cylindrical barrel or something similar. But you will see things like this very often on the AP exam. There's guaranteed to be at least one of these questions. So yeah, as you can see, they've given you volume of the cone right here. It's 1/3 pi r squared h. Not triangle. Here you'd have to derive a ratio between radius and height, but as you can see, they are the same here. And they've given you volume. Yeah, you might have to change h to r so that you can plug in stuff. Yeah, that's correct. False. That would be the way to go about things. Like, the easiest way for me personally is, as is, I just take the derivative of whatever formula I'm given, right? And then I see, okay, what can I plug in? What can I not plug in? And to solve, what do I need to find? And then from there, you can go about plugging in things and substituting to find values. Yeah. Yeah, it is lemon. Okay, MDM, I think that's correct. Good job. But do remember to use units. Do remember to add the correct units to your answer. Yep, that's correct. And yeah, once again, remember to add units. Yeah, good job. Yeah, when solving these problems, please remember to add units, because it's like literally the most simplest way to gain points. I'm pretty sure in most cases you will actually just get a point for putting the correct units, even if your answer is like incorrect or off by a little. So yeah, it's just whenever you get the chance or whenever you can, make sure to add units to your answer. Yeah, it is a little more difficult, but yeah, once again, see if you can try and draw it out, visualize it, see what's changing, see what's not, label everything, and then see if you can go from there. Yeah, Boreas, that answer is correct. Good job. How much time? We'll probably end this question for like another 2 minutes, 2.5 minutes. It says height equals 4 because that's the height of the water inside the cone at that moment. Yeah, it is mostly just about how you tackle it. Yeah, when it says height equals 4 in the problem, it's talking about the height of the water. So you can think of the water as a smaller cone with a height of 4 centimeters inside the larger cone with the height of 10 and radius of 10. Yeah, radius of the cone is a constant here. But height of the radius of the water inside would not be constant. I think you could just convert radius to height or find a proportion and then substitute. Well, here, since they've given you h twice, it would be safer to change r to h. Yeah, sunflounder, that's correct. Here, since they haven't given you any measurement for radius of the water, it's safer to convert radius into height using a ratio. You can leave it out throughout your solving, just make sure you put it onto your question, put it on your final answer. Yeah, don't worry if you feel a little stuck, because I will show the solution and then go over it with you guys. So just try your best. If you can't figure it out, that's okay. We'll look at it together. Alright, I'll give it like another minute or so if anyone else wants to try to answer. If not, then 4.6, no, because we already covered implicit, so this might be something else. I can't remember off the top of my head, but it's, let me see. Yeah, approximating with linearization. Had it and lost it. That's unfortunate. No, L'Hopital was last lecture. That's in units 2 and 3. Really? Okay, well, actually, no. L'Hopital's, I think L'Hopital's our last topic, actually. Yeah, okay, then it's probably our last topic. It'll be 4.7 then. Yeah, okay. Yes. Yeah. 100 on your test, but forgot everything. It happens. Okay, I think I've given enough time. It doesn't look like they've given a or I guess I forgot to include the solution, so I'll just pull it up on the side and solve real quick. Yeah, there are only about 3 weeks left until the exam, so 1/3. I don't think that's correct, Ray. Might be a little off. Okay. Yeah, okay, well, I'll solve it right now. So, say we have our cone right here, correct? So, there's water going in at a rate of 2 cubic centimeters per second. And then, as we were told, this radius is 10 centimeters. And this height is also 10 centimeters. So this is not drawn to scale. So what we do now is we're trying to find the rate of change of the height of the water. So this, like, moving upwards is dH dt, which is what we're trying to find, right? And then we're trying to find this when this height of the water is 4 centimeters. So to do this, right, first what we want to do is we want to get a ratio for the radius to height, because we want to find the volume of this and then solve accordingly. So here for this water, right, since for the bigger cone, which is, this means the radius to size ratio of this water is going to be the same as the radius to height ratio of the cone. Yeah, it is essentially a similar triangle. So here the ratio is 1 to 1, which means R equals H, right? So in our formula here, V equals 1/3 pi R squared H. We can swap out R squared or R for H, which just becomes H squared instead, times H in here. So with this in mind, right, this means our new formula is now V equals 1/3 pi H cubed. Okay, so given this formula, if we now take, if you don't swap R with H, will I get a wrong answer? No, but they haven't given us the rate of change of the radius. So if you were to derive, you'd end up having to do product rule, and then you'd end up with dr dt, which you don't know and have no way of finding. So it'll make it a lot more complicated. So that's why you swap out R for H here. The derivative, the radius of the cone is a constant, but how do we get R equals H? Well, radius is 10 centimeters, height is 10 centimeters, so it's a 1-to-1 ratio. R derivative isn't 0 because while the outside cone's radius stays as 10 centimeters, the inside cone's radius will increase as it fills up more and more. So that means the radius of the water within is changing, but we don't know at what rate it's changing. So that's why we swap out R for H. So that way we only have to deal with the change in height. So then, yeah, from here, we're just going to take the derivative of this volume formula. So that'll give us dV over dt. is equal to, bring the 3 down in front, so we just get rid of it. So now we just have pi times h squared times dh dt, right? Thank you. But yeah, given this, right? So we have our height right here, 4 centimeters. This is our h. This right here, the 2 centimeters per second squared, or 2 cubic centimeters per second. That's the volume, correct? And that's all we need to plug into here. How do you know when the radius is or isn't constant? Well, think about it, right? Because the cone gets wider and wider as you go from the bottom to the top. So if the water is filling up that same cone, then the cone of water, or the top layer of the water, is also going to get wider and wider and wider, meaning the radius will increase. 1 over 3, yeah, it gets multiplied by the 3 from h cubed, because you're taking the derivative. Is there any problem with writing r prime instead of... No, there isn't any problem, as long as you get the same answer. However you write notation is fine. But yeah, now that we have this equation down here, we can simply plug in our h and our... We can leave dh dt, but we can also plug in dv dt. So you end up with 2 equals pi times 4 squared times dh dt, right? So this then becomes, then becomes, 16 pi dh dt. I just moved stuff to the other side, equals 2. So now if you divide by 16 pi, you end up with dh dt equals 2 over 16 pi, which simplifies down to 1 over 8 pi. And this is the final answer right here. Ah yes, units. Thank you. So yeah, since we're dealing with height here, height only is in centimeters, so this would be centimeters per second. Yeah. I guess with physics it's important to isolate a little because things can get complicated fast, and it's better to like have everything in its simplest form before you plug in. But honestly, it's up to you when it comes to calculus. Alright, does anyone have any questions regarding this problem, or just like related rates in general? Or are you guys ready to move on to linearization? Is doing calculus worsen my back pain? Probably, maybe. Can you go back to the question? I want to take a screen. Oh, of like the question on the slides? Yeah, give me a second. Right, you wanted the question on the slides, right? Yeah, okay. Yeah, I'll just take a screenshot, send it in the chat. Probably be easier. And yeah, I sent the lecture schedule earlier. I'll send it one more time, just for anyone who wants to tag along with the slides. So there's a lecture guide, once again. If you scroll down to AP Calculus Unit 4, then you should see the slides there. Should be able to access them as well. Make sure you go to list view though, at the bottom. There is no Unit 11. Unit 12? Whoa. Back pain. Yeah, no, there are only 10 units of calculus. Okay, looks like most of us know what we're doing. Can we move on? Is everyone ready? Okay, okay, well, I'm gonna move on, but so, um, calculus BC has 10 units, calculus AB has 8 units. That's the structuring for AB and BC. BC adds units 9 and units 10. Right, instead of figuring out the derivative of R, you switch it out for H, and then just take the derivative there. That's why we had R equals H, and then H cubed. Okay, so this is approximation. Now, I know this looks a little whack, but this is quite literally just point slope formula, but slightly rearranged. So essentially, when you're trying to approximate a value, you can take the value of another point and then add the derivative times your initial x value minus the other x value. So the only time you ever use this is when like the value you're trying to find and a value you already have are pretty close to derivative. Yeah, take like the point, differentiate another point, and then you can like solve for approximation and stuff. But yeah, when you're doing this with approximations, you need to take the second derivative and look at concavity, because what concavity does is, depending on whether it's concave up or concave down, right? Approximation of your tangent line might be slightly off. Like if we look at this graph, right? Here it's concave down. So when we take the approximation, right, of like a different point on the graph, you can see that the tangent line is giving us a higher value than the actual value of the graph, right? But here, if we took the same thing, then the tangent line would be below the value of the graph. So if you were to take the derivative here, but then approximate the value here, the tangent line would be somewhere over here, which is below the actual value. So keep in mind that if your function is concave up at the point you're taking the derivative, or the point you're trying to find, your estimation will be an underestimate. And at the point you've taken the tangent line, if you are going concave down, then you will overshoot. It'll be an overestimate. Newton's method comes much later. It requires a lot of plugging and solving for zeros. I think we'll cover that in Unit 8, I believe. I think that's when that shows up. Or at the end of Unit 7, I believe. But okay, so use linearization real quick. It's a quick sample problem. So try using linearization to approximate the square root of 4.1. So here, since it's not very obvious, the function we're using is the square root function. So this is just square root x, where we've plugged in 4.1 for x. So going back to the previous slide, right, we have square root 4.1 is approximately equal to square root of probably 4 in this case, plus the derivative at 4 times 4.1 minus 4. That's how you go about approximating the square root of 4.1. And yeah, as we covered in the last lecture, the square root, or the derivative of the square root function, is 1 over 2 times the square root of x. So yeah, give this question a try, and then type your answers in the chat. How do we know x is 4.1? Because, like, assuming this is the square root function, then you'd plug in, it would be root x. So, x in this case is 4.1. Yeah, it's correct. What do we need to find? You need to approximate 4.1. So, the function here is the square root of x. And try plugging in a value into the square root that is close to 4.1, and we'll give you a nice whole answer if you square root it. So in this case, try plugging in 4 for a based off of this formula right here. So x is 4.1, a is 4, and then you're finding the derivative of square root x times 4.1 minus 4. Yeah, it's correct. It's also correct. Yeah, you can write it like that. That works. That's correct. Good job. I think most of you were able to remember this pretty well. Yep, that's correct. Yeah, that's also correct. Yeah, I was like, I don't think you really need a calculator for this one. You can probably figure it out by hand. Okay, I guess most of us have answered, so I'm gonna go show the solution really quickly. Okay, let's see if Ray got this correct. Yeah, okay, good job. So the answer is 2.025. So based off of our function earlier, right? You're trying to find, we can use f of x is equal to the square root of x, and we use a equals 4. Now we're using 4 because it's pretty close to 4.1, right? So that means the closer our x and our a are, the more accurate our estimation is going to be. Okay, so that's why we use a equals 4 in this case, and also because if we plug it into root x, we get a nice whole number, 2, right? We don't end up with like square root of 3 is like 1.7 something, which becomes really messy and hard to calculate. So here we use 4, right? If we take the derivative of square root of x, we end up with 1 over 2 times the square root of x. Now if we plug in 4 into here, we end up with 1 over 2 times the square root of 4, which is 2 times 2, which is 4. So you end up with 1 over 4. And plugging in 4 into f of x gives us 2. So you end up with 1/4 times x minus 4, which is our a. So this is the f prime of a times x minus a plus f of a. So if you solve this for 4.1, you'll end up with 1/4 times 4.1 minus 4 plus 2, which is 1/4 times 0.1 plus 2, which is 0.025 plus 2, which is 2.025. So that's your approximation. Alright, any questions on this problem or on this topic? Could you have a mixed fraction? Recommended not to, but it should be fine. If you end up with a mixed fraction, I'd say it's safer to write it as an improper fraction instead. Like if you end up with like 7 and 4/3, then just do 25 over 3 instead. Yeah, it's essentially just point slope formula. Just think of point slope formula. If you like, imagine point slope formula, but you're solving for y. Because you know how point slope is like y minus y1 equals slope times x minus x1? You just add y1 to the other time, right, to the other side. That's all this formula is. It's just point slope, but you're solving for y. Yeah, 81 over 40 would be better in this case, rather than like 1 or 2 and 1/40th. Okay, you guys ready to move on to the next question? Or next topic? This would probably be an MCQ. I doubt they would give you this as an FRQ unless it was a calculator section and something slightly different. Fraction solution, it's up to you, honestly. If you can use the decimal, then round to 3 places. But if you're getting a improper fraction that you don't know how to simplify, or there is no simplification, then you can just write it as is on like any FRQ, and you'll get the points for it. Yeah, like sometimes you'll have to write in a decimal because you'll have to plug stuff in and it will give you a decimal. But if you end up with a fraction answer, you don't necessarily have to convert to decimal, unless like it's an MCQ and all the answer choices are in decimal. All right. Okay, I'm gonna move on then to the last topic, I believe. Okay, so this is a really nice part of calculus right here. Yeah, you can also leave stuff unsimplified. On FRQ you can't. You'd have to simplify any fractions fully, but on MCQ and your work you can leave stuff unsimplified. Or the unsimplification can be there for like FRQ derivatives and stuff. For really big derivatives. But yeah, so this is topic 4.7. So this is L'Hopital's rule. You may see this written as L'Hospital's rule on your test because College Board cannot spell. I have seen that before, so just be warned that might be a thing. It's referring to the same thing, so rest assured. Yeah, alright. But essentially what this is let's say you have an indeterminate form limit that ends with you getting like 0 over 0 or infinity over infinity, right? Because you plugged in something and it gave you, like, let's say you're taking an infinite limit and you end up with infinity over infinity. Then what you can do is if you take the limit of the numerator and the denominator separately and they both reach infinity, yeah, if you get an indeterminate form and you L'Hopital and it's still indeterminate, then just L'Hopital again. If you're experiencing audio issues, then leave and rejoin. It should fix itself. Yeah, genuinely just spam derivatives here. Yeah, so if you end up with like some weird indeterminate form where it's like 0 times infinity or something, you can write it as like 0 over like 1 over infinity, because 1 over infinity is 0, so you'll get 0 over 0, which is an indeterminate form that you can actually solve. Yeah, L'Hopital is really nice for any like limit problem, so that way you don't have to like deal with like conjugates if they're weird stuff. You can just take the derivative of the top and bottom. Makes it really easy. So, okay, let's do a practice problem real quick. I think this should be pretty easy for all of you guys. So, evaluate the limit as x approaches 0 of sine x over x. Now, most of you might know the answer here by default because it's a standard limit. No, that's fine, that's fine. It is 1. But if you do L'Hopital's here, it'll show you why it's 1. So this explains the definition of the basic limits. Yeah, correct, Boreas. So remember, when showing your work for this, you can, on the AP exam, you can simply write indeterminate form, comma, L'Hopital's rule, and then jump straight into taking the derivative. Like, show that the original limit is equal to the limit of the derivative over the of the top over the derivative of the bottom, and then you can plug in and solve. Yeah, this is the basically. That's only if they ask for whether it is or not. I'd recommend that you show yourself like switching from the original limit to the L'Hopital limit at the very least, because they might get. Accordingly, L'Hopital rule, if I have a sequence. Any limit problem that L'Hopital doesn't work on? I don't think so. But yeah, integralist, as for what you're asking, I believe that is correct, yes. Yeah, you can also use small angle approximation. Okay, Mouse, what are you getting confused on? Or what's tripping you up here? No, it wouldn't always be over 0, because remember, you're taking the derivative of the top and the derivative of the bottom separately. It's not quotient rule here. Atoms, don't worry about understanding it. That's mostly just BC stuff and series. You'll get there eventually, though. What if I get a number on top and a 0 on the denominator? Then that's a vertical asymptote, which is separate. It's not indeterminate form. You're taking BC this year? Yeah, Dragonfire, you're a little late, but we're not quite done yet, so. Alright, well, I guess most of us got this figured out. So, yeah. Solution, it's 1. The limit as x approaches 0 of the top and the bottom is 0, so you end up with indeterminate form. And then if you take the derivative of the top and the bottom, you end up with the limit as x approaches 0 of cosine over 1. And now if you plug in 0, you end up with 1 over 1, which is just 1. So this is why like this identity exists, is because you can prove it using L'Hopital's rule. Yeah, 6 and 8 are the hardest. I would say they are the hardest parts of AB. 7 isn't too difficult. It's a little easier than bro, skipping unit 7 is crazy. I believe 6 is I think it's applications of integration. I think that's what it is for unit 6. Ah, 6 is just integration, and I think 7 is applications, and 8 is volumes. Yeah, I believe unit 7, differential equations. Oh yeah, differential equations are really easy. It's just, it's like one form, that's all. Yeah, application is volumes, yes. Yeah. well, anyways, another quick problem here. This one's a little tougher than the last one. If audio isn't working, then leave and rejoin should work. Asymptotic form. Yeah, I am talking right now. Yeah, okay. Well, yeah, integralist, that's correct. The rest of you guys try this problem out real quick. Yep, that's correct. That's correct. Yeah, asymptotic form will make El Hospital not work. How do I do spoiler? Use a slash spoiler and then tab and then type your message, or use two vertical lines. Yeah, anything outside of indeterminate makes L'Hopital's not work. Yeah, here you just take the log of both sides, or the natural log, so I think you do change of base here, so you get log B over log A, and then you can figure things out from there. Yeah. I mean, also here instead of log rules, you could genuinely just plug in 0 to the power 0, and then anything to the power 0 is 1, so yeah, that also kind of works in this situation. L'Hopital is for indeterminate form, so 0 over 0, infinity over infinity, or like 0 times infinity, or infinity minus infinity, things like that, where you can't really get a concrete answer, a concrete finite answer. Yeah, this one's also an indeterminate form, like 0 to the 0 or infinity to the infinity, because there's no like given answer that you can just solve for as is. Yeah, it is just 1. In this case, you can just do to the power 0 is 1, and it'll give you the correct answer. Yeah, I'll put the, if you check the core, if you check the lecture guide, it'll be there, or the lecture schedule. Yeah, infinity to the infinity is just infinity. How do you do it with log? I'll go over the solution real quick. Can this meeting be recorded? Yeah, it'll be on the YouTube channel, and I'll link it to the lecture guide that I just posted. It's currently being recorded. Alright, solution time. So, what you're going to do here is, if, let's say we assume that we're going to let y equal x to the power x. So we're going to give it a function, right? We're going to say x to the x is a function. If we take the ln of y, then we end up with ln of y equals x times the ln of x, which is the same thing as the ln of x over 1 over x. You could direct substitute, but this would be the more proof-y way. This is like this is a more concrete method here. Because with 0 to the 0, you could it could get confusing. Because like 0 times anything should just be 0, right? But this way it shows clearly that it is 1. So if we do this, right, then if we plug in, if we take the limit as x approaches 0 of ln of x If it's for an FRQ, you have to write out the whole proof. You would probably have to write this out, yes. Most of this, at least. I haven't seen this on an FRQ, though, before. Like, you'll never see x to the x as an indeterminate form. Whenever you're dealing with indeterminate form, it will always be... Like, as far as I've seen, it will most likely just be 0 over 0 or infinity over infinity. That's the only indeterminate form you'll probably encounter on the AP test. Yeah, so the way you solve this is ln both sides, natural log both sides, and then rearrange into a fraction. So you end up with ln of x over 1 over x. Now if you take the limit as x approaches 0 of both, you end up with negative infinity over infinity, which means you can now derive both. So you end up with 1 over x divided by negative 1 over x squared, which simplifies to negative x, which equals 0. And then the natural log of y equals 0, which means y equals e to the 0, which is 1. So that means x to the x equals 1. You're using natural log because at the end you can then just do e to the whatever and cancel out the natural log that way. If you did log, you'd have to use change of base and anything else. Instead of going to the YouTube channel for the videos, I'd recommend just clicking the links in the lecture schedule. The thing is next to them, and I'll add Unit 2 and 3 lectures video there as well. Yeah, if you're going to use log, then you'd use 10 to the thing instead of e to the thing, because they are full-length lectures. It'll, like, whatever I covered in the last lecture last week and the one before that are fully recorded and on the lecture guide. Okay, so now the part that everyone has been looking forward to, I'm sure. We're doing a Kahoot game. So I'm gonna stop screen sharing for a little bit so I can set this up, and then while I'm at it, I'll add last week's lecture to the lecture guide as well for anyone who wants to check it out. So if you're on the lecture guide right now, and if you're looking at AP Calculus, then last week's lecture should be in. Okay, and okay, Kahoot. Okay. Let's just keep going, I guess. Okay, the Kahoot should be up and running, so feel free to join. I'll change the settings so you can see the questions. You can look at them on your own device, so you won't have to have this screen share open all the time. Oh, the full-length lectures, check the lecture guide. They're right next to the... Yeah, my videos are currently unlisted on the YouTube channel, but if you go to the lecture schedule, then they'll be next to their respective slots. Yeah, if anyone wants it, then here's the lecture schedule. Yeah. Is there a link to the Kahoot? I'll add that in the notes section. Actually, that's a good idea. I'll add that afterwards for both Unit 1, 2, 3, and 4. So yeah, after this lecture, feel free to go check that out if you want to review the kahoots we did in the last lectures and play along, I guess. I'll add those in there. Props for using Opera GX. Thank you, thank you. Yeah, as Reading said, if you want to check out last year's lectures, then please go check out the 2025 lecture. Do they cover all units? Yeah, we'll be covering most of the units. Anything that has been missed should be available in last year's lecture, so if you want to like look ahead, you can do that. We should still be doing AP Bio this year, I think. I just don't think the lectures have gone underway yet. You can definitely check out last year's lecture schedule though, and that will do you get volunteer hours? Yes. This is all just volunteer hours. It's entirely volunteer work. I'm not getting paid for this. Also, Marshmallow, if you want AP Biology's lectures, then go check last year's lecture schedule, because that'll have recordings of last year's bio lectures, so you can cover those. Yeah, thank you. Yeah. Alright, I think most of the people have joined. Thank you for being here. Yeah, of course, it's my pleasure. Not a problem at all. Alright, I don't think anybody else is joining. Even if you want to join, the game link will be at the bottom, or the ID will be at the bottom, so just type it in Kahoot and you'll get that. Alright, let's get started. Yeah, once again, you will be able to see the questions on your own devices, so if you want, you can have the screen share open. You don't have to though. Yeah, so there's 4 minutes per question. I think I'll keep it to like 2 minutes, because it shouldn't take that long to solve these. I don't want to sit here for like an hour just doing this. Saw the prime and guess without reading. Not a bad strat, but not the greatest of all time either. Yeah, that is true. Like Boreas said, the function could have been a rate, so you'd be taking the double rate. I believe these are from a past AP MCQ, and I believe there's some practice websites that have MCQ style problems on them, so yeah, option C would be a double derivative question. Yes, that would be the answer for a double derivative. Okay, looks like the majority of us got it right. I think some of us got tripped up a little. So if you look at C, right, we're given that W of T is the amount of water. So we're taking the rate of change of the water, right? What C is the rate of change of the rate of change. So if W of t was already a rate, then option C would be correct. But option C here is like a double derivative, and it's only asking for the first derivative. So yeah, option B is the correct one here. Okay, looks like Adams is in first place. Good stuff, good stuff. Alright, question number 2. So, the rate at which acorns are produced is represented by A of t. So keep that in mind. A of t is representing a rate, not an amount this time. So now they're asking, what is the best interpretation of the derivative of A at 3? Uh-oh, do we have a... Oops. Yeah, make sure to read these problems carefully. Just joined? Okay, well, you're not that far behind. We only just did one question, so you can still catch up. But in this case, we're dealing with the derivative of a rate. So the rate of change is increasing and decreasing, not the amount produced. Yes, this is a second derivative. Okay, looks like we didn't make a mistake. I think we just need one more person to answer. That should be it. How much timer for every MCQ question on the Calc AB? Well, you get 60 minutes for 45 questions, so you'll get around a minute for each question. What is the most common unit for? Yeah, it is related rates. I think related rates will be worth the most because it'll be there on the FRQ. One person picked D. That might have been a misclick. Okay, so yeah, I think we had the same thing happen here as last time. Here, this time, since A of t is a rate, now the double derivative option is the correct one, because now the rate is increasing or decreasing instead of just the number of acorns. If that makes sense. No, optimization is unit 5, yeah. Yeah, just when you're answering these questions on the test, just take it easy. Clarify what's what. Don't mess up too much. And yeah, you guys got this. Okay, looks like we have a new first place by 3 points. Close game. How to quickly solve shortest distance questions with optimization? You kind of just have to figure out formula for distance, and then, because you'll be dealing with rates, so just figure out what you're dividing by. Uh-oh, we have a misclick. Yeah, this one's pretty simple. Just plug into... Yeah, this would be an actual question. Something similar to this. Yeah, if power rule isn't a thing, you'd have to just derivative definition everything. When to do double derivative? Well, here you see r of t is said to be number, right? If this said rate of change instead of number, then you do double derivative, because now you're taking the derivative, rate of change, of a rate of change. Okay, I believe there's only one more person left. Okay, looks like a lot of us got that correct. That's a majority. It's better than the last two questions. So yes, the correct answer here is 12. Because remember, you're not plugging in 2 into here. It's you have to take the derivative first, so it becomes 3t squared. And then if you plug in 2, it becomes 3 times 2 squared, which is 3 times 4, which is 12. I'll probably be cutting the question time down to like 2 minutes because I don't want to spend that much time on these. Okay, so here we have a rate and we're looking to see whether the number is being increased. So we're trying to find amount based off of rate instead of rate based off of amount. Yeah, these questions are definitely easy. Okay, we need 2 more people to answer. So FTC in that context is the fundamental theorem of calculus. Okay, that should be. There's only one person left. Yeah, I'll probably just skip that 14. This one person seems to be taking a little bit. Okay, so yeah, the answer here is A. Because remember, we're not looking at, or hold on, which of the following statements would justify that the number of pineapples? Oh dear, looks like, yeah, it is B. Yeah, okay, looks like the Kahoot has the wrong answers, which is unfortunate. Yeah, you know what? I should probably like vet these Kahoots before I just send them to you guys. Anyways, it is B. Because, okay, look, because it's given us P. Or actually, no, it is A. It is A. It actually is A, yeah. Because, yeah, okay, I'm not tripping. Yeah, because the given is a rate. The given is a rate. The given is not an amount. So that means the rate itself is increasing. So it was just the given. Because look, P of t, right? The P of t is the rate. So if the number, yeah, if it says rate, that is a derivative. So P of t is the rate. So if you want the number to increase, then the rate has to be positive. So that means that the original function has to be greater than 0, not the derivative of the given function. So yeah, this is a little bit of tricky question. If the rate is increasing, then the double derivative has to be positive. That's that option would be B, but the correct option here is A. But yeah, you guys gotta make sure to read YA because this is rate already. The function is rate. So rate has to be positive for number to increase. Okay, well, moving on to the next question. Looks like a few of us got that correct. Yeah, make sure you are reading these carefully because they will throw a curveball like that at you on the actual exam as well. Okay, next question. Okay, looks like this one's a little zoomed out. Zoom in for those of you looking at the screen share. Okay, so remember, original function here is rate. W of t is a rate, and R of t is also a rate. So they're asking you to find the rate of change of the amount of water that the tank is decreasing at t equals 1. So W1 is the entrance, R of t is the exit. So entrance minus exit, right, would be amount. Questions other than stuff like this? Maybe. Yeah, it's mostly all just going to be rate questions. There might be related rates questions later on. We talk about unit 9 and 10 much later. Okay, looks like everyone's got it pretty much. Guess one person might have left. I'll see. Yeah, correct answer is D here. I guess I don't think we read again. I think we might have forgotten to read. Some of us. Okay, so W is the rate in, R is the rate out, right? So that means when talking about the amount of water, W is positive and R is negative, right? R is taking stuff out of the amount. So W minus R is the amount in minus the amount out, which is the amount of the water inside the tank, right? But if we want the rate of change of the amount of water inside the tank, then we need the how much is like, yeah, I wanted to know whether the rate is increasing or decreasing, not what the rate is. C won't be positive. C would still be negative, right? But it's asking for decrease of the rate of change. So W minus R gives us the rate of change, but they're asking whether that rate of change is increasing or decreasing. So it's rate of the rate, yeah. So double rate here. Yeah, this is why we're going over these questions, because this is literally like exactly what will show up on the test. So at least it's good that we're messing up. Yeah, it's good that we're messing up here, because that means later on we should be doing better. Okay. Next question. Okay, so v of t, velocity, has been given by the graph, and it's asking on what intervals is the particle moving to the left. So it's moving to the left when velocity is negative. So looking at the graph, for what x-axis, for what t values is v of t negative? Oh, okay. It's like a couple of people have left, so... Okay, looks like we have 100% correct. Did someone not answer in time? My apologies, my apologies. Okay, well... Okay, looks like idiot might not be an idiot after all. I'll have to see how this ends. Can I explain how? You just looked where the graph was below the x-axis there, because it's velocity. So if you want velocity to the left, then that's negative velocity. So you look where the graph is below the x-axis. Okay, this one's a little more complex because we need to find both acceleration and velocity. Yeah, it is a speed question here. Yeah, the last one would be velocity only. Fumbled due to another potential misread. Unfortunate. Okay, have all of us answered? Okay, I'll see how many are left by the time we finish this one, then. Okay, so it looks like there are 13 people. Okay, it looks like we're getting this constant 9-4 split here. But yeah, the correct answer here is A, because when you plug in 1 here for velocity, you'll get 2 minus 6, which is negative 4. And when you take the derivative, you get 4 minus 6, which is negative 2. So since it's both negative, the particle is speeding up. So even though the velocity is negative, since acceleration is also negative, right, since the signs match, we speed up. If the signs were different, then you'd slow down. Okay. I think we'll just go to question 10 because till question 20 will probably take a while. Alright. Okay, so given position, right, on the interval, they're asking you to find at what t values is the particle at rest. So where is the velocity of the particle equal to 0? Uh-oh. Oh no. this is velocity, because for it to be at rest, velocity has to equal 0, which means it's not moving. Yeah, straightforward questions are definitely very nice. If it says speeding up or slowing down, that's sign comparison. If it's at rest, then velocity. I think it's... Yeah, of course. I'll have lectures. I mean, depends on whether some of the other lecturers will decide to cover the next units, but if not, then I'll probably review all of calculus. Yeah, so this one was a question where you just use velocity. Because here it says at rest, it's not mentioning speeding up or slowing down. When it says speeding up and slowing down, that's, yeah. When it says speeding up or slowing down, that is double. If not, then you don't have to. Yeah, speed is the keyword. Yeah, it's because speed is scale. Yes, correct. So yeah, here you take the derivative and you'd get half, negative half of sine t. So sine t over 2 equals 0. Okay, I think I can... So like, v of t becomes 1/2 negative sine t of halves, and you set this equal to 0. So velocity, when velocity equals 0, that is when... that's when the particle is at rest. So we remove the negative 1/2 by dividing both sides, and then we're trying to find where sine equals 0, so that happens at 0 and pi. And then we get t over 2 equals 0, comma pi, comma 2 pi, comma 3 pi, whatever. So then you just multiply by 2, so you get 0, comma 2 pi, comma 4 pi, comma 6 pi, comma 8 pi, and so on and so forth. But since we're on the intervals 0 to 2 pi, our answers are 0 and 2 pi. Are there any questions about this, or? No, not chain rule. Or wait, chain on this, right? Yeah, this would be chain rule, yes. Yeah. Yes, okay. Don't you get 1 when cosine 2 pi? No, because you have to take the derivative using chain rule, and that'll give you negative 1/2 sine t over 2. Because that's velocity, because this is position, and we need velocity to be equal to 0, not position. Alright, 2 more questions. Let's see if anyone can overtake Boreas. Okay, so position has been given by e to the 2t minus 1 for t greater than or equal to 0. So they're asking, what is the acceleration of the particle at t equals 0? So you're going to have to take the derivative twice here, and then plug in t equals 0. Yeah, this is the final Kahoot. Sorry about that. Alright, I think we have one more problem after this, and then that should be it. Unless you guys want to play to like problem 15. It's up to you guys. Yeah, I'll post the link on the lecture schedule if you want to leave now, so that you can go through it by yourself later. Problem 15. Okay, are there any objections? Do you need to hop on AP Chem? So that'd be awesome sauce. Okay, I think we'll stop here at question 10. I will post the link to this Kahoot in the lecture schedule so that you guys have some time to get ready for any other lecture you're attending. And then yeah, we'll have a small Q&A after this, and I'll show you guys some resources you can use, or I'll talk about some resources you can use. And then yeah. Okay, I think that's everyone, so I'm gonna go ahead and skip here. Ooh, I think we might have had some misclicks. So remember, v of t needs to be 0 for at rest. So we're basically looking at where v of this graph intersects the x-axis, and that's at 3 and 6, so that's why the answer is C. Okay, I'm gonna go ahead and end that. Alright, let's take a look at the podium. Okay, Droson in third, Idiot in second, and Boreas in first. Congratulations. Good stuff, guys. Fourth place, so close yet so far. Okay. Back to this really quickly before you guys decide to head out. Here's a couple of resources if you guys want to look them up. Like going to OpenStax, Khan Academy, and Paul's online notes would probably be the best if you're going to self-study or want to study by yourself. You can look up FRQs and for AB and BC. Yeah, you can use any source you want to study. Low-key, these are just some of the recommended ones. Slideshow will be up on the lecture schedule along with the link to the Kahoot. What other units am I covering? I'll probably cover Unit 5 as well, and then someone else is probably going to cover Units 6 and 7. And then if they need me to cover for them, then I will cover those 2 units. And then I think the next one I'm going to do is Unit 8. Yeah, I'll be covering 8, and then I think I'm splitting 9. 9's being split into 2 lectures, or I think 10 is being split into 2 lectures, because series is pretty long. So, yeah. I think that's the schedule for the next couple of lectures. Alright, well, really quickly, before you head out, I'd really appreciate it if you guys filled out this form right here, because this basically helps me improve on my lectures, and it'll help us make better ones in the future. So if you guys could copy paste that link, or just look at take a picture of the QR code, and you should be fine. Yeah, series is rough. Yeah, of course, no problem. It's my pleasure to lecture for you guys. Happy I could help you guys. What's with the gifts? Viewer retention. Yeah, of course, no problem, no problem. That's good to hear. Yeah, of course. I believe it should be same thing next week. True, we do need the Subway Surfers gameplay. I'll see if I can switch it out next time. Alright, well, that's pretty much it for today's lecture. If you have any questions, feel free to ask them now. And otherwise, thanks for dropping by, and yeah, good luck on your guys' AP exams, whatever other lectures you might be going to. I hope you enjoy them, and yeah, best of luck and have a great day.